Let's take a look at an example of a scatter plot problem that ends up being quadratic. Now keep in mind, the assumption is that you already watched the video on how to do this with the TI and with Desmos, and you understand what I mean when I say hit stat or edit. There's a video on that you might want to go back and look at if you have not. So the following data follows a ball that is being thrown by a baseball player, and somebody's measuring the time with a stopwatch, and someone else is measuring the height, and this is the information that they recorded. So in the TI, you would hit stat, and you would go to edit, and you would enter this in exactly like you see, this being L1 and this L2, and then you would, once you get it in there, you would stop, and then you would immediately hit the Y equals button and turn the plot on. Once you turn the plot on, you're going to hit zoom and hit 9, which is zoom stat, and you'll get this picture. Okay, if you're typing that in during the video, you might want to hit pause and get to here. So once you do that, you're then going to go back to stat and go to calculate, okay, and you're going to calculate the quadratic regression model because this looks approximately quadratic. So then once you do that, you're going to, this will show up. Notice it says quad regression right here. To put Y1 here so that you can actually draw the curve, you hit alpha F4 and hit Y1 when you're blinking right here. Then you hit calculate, and this information will show up, giving you your A, B, and C to model quadratic. And if you go back to Y1, it'll show you your data with your model so you can eyeball and see that it's pretty good. So how do I do it on Desmos, especially for my students who are going to be taking this test possibly on online or on an SOL? Well, you first start by asking yourself, well, where is that table? Again, it's found under the plus sign, and it says table, and you just take a second and type it in. Make sure you don't make a typo, just like you did if you were to use a calculator. And once you do that, once you type those in, notice that you're typing them in to X1. Now, why is it important? It's important to understand that in a TI or a Casio, they don't necessarily label these this way, right? So that makes sense that it would be X's. And over here, we're going to put in this. All right, and notice that as soon as I start doing that, you start seeing points show up on the right-hand side of the screen, which is awesome. Remember, you're in the Desmos graphing calculator. All right, and so now that you have that in there, what we're going to do is we're going to come over to our graph, and it's kind of a mess. So we're going to hit the wrench, and we're going to change the axis, okay, to match the domain of the information, but not exactly, like a little bit more. It starts at 0.25, so I'm going to put in 0. It ends at 1.75, so I'll put in 2. I can even label this as time, which is what it says over here. I can change the step if I wanted to, which is, how many tick marks you see on the graph. For the y-axis, the range, appears to be 4 to 28, so I'm going to put in 0 to, I don't know, maybe 30. Just make it bigger than the information you see, and you can add a label right there and say that's height, which is very convenient. All right, so once I do that, I can immediately get out of here by just clicking the wrench again, and I can see, oh, there's my data. I can even, if it's not quite good enough, I can fine tune it by hitting the zoom out or zoom in buttons, and I can scroll it around by doing this. So I look at this information, and that information, it kind of looks like a triangle, but it's very, very up and down, which makes it quadratic, even though it is kind of triangular. Remember, this information that we got was recorded by a person, and people can make little boo-boos. So what I want to do now is I'm going to take this calculator, and I'm now going to type in the model. I know what it is in the second blank. It is y equals ax squared. Make sure you go down or click down right here and put in plus bx plus c. That's the model we learned in class. Now you might say, okay, that's good, but it's not doing anything. Well, the reason it's not doing anything is you're saying equals, and you want to say approximately. And you can either use the button in the upper left corner of your keyboard, or you can toggle the keyboard on Desmos and hit the ABC button to get rid of all the numbers, and it's right here. Okay? Now, it still hasn't done anything, and the reason it hasn't done anything is this chart is labeled X1 and Y1. So you just come over here and you use this to put in the subscripts, and then as soon as you put in the last subscript, it will immediately calculate it. Watch. Boom. There it is. It even drew it for you. Okay? If you don't like the coloring, you can, of course, change that. You can make, the graph the same color as the point or what have you. So these values right here, they are identical to the values that you saw in the calculator on the TI. right? The TI just gives you a couple more decimal places, but there they are. And so I guess the question is, what do you do with this information? Either way you find it. Either you find it on the TI or on Desmos. Desmos is great. It has everything you need. So if you needed to update anything, it's all on the screen. On any calculator, it's going to require you to know what button to press. So what you do, is I always have my students make a sketch of what they see. So I just ask them to just, you don't have to draw the exact thing. Just make a sketch of what you see. That way I know that you actually went through the process. And then once you do that, you actually have to write out the equation. And notice what I did here is I wrote it out as h of t. It's not really a y anymore. It's really height and time. So I wrote it out as h of t. I changed the x's to t's, and that's going to be very important in the next step. So the purpose of this is not just to learn how to use calculators. The purpose is to use this to do something. So the first question we actually have that actually requires us to do something is right here. It says predict what the height of the ball will be at 1.5 seconds. And so, on the TI, there's actually a feature called the table, which is going to be second graph, and you can just plug in 1.5 and it'll give it to you, which is really neat. I mean, that's very handy. But on Desmos, all you have to do, right, is you come to your model here, and if that is y1, then you would have to just rewrite that as what we typed above. So we're just going to call that h of t is equal to negative 32.5524x squared, and then plus 70.8619. If you were really creative, you could, copy that and put it in. So actually, it doesn't let you. I'm surprised. And so, forgot to put in my constant there. All right. So x, and then those need to be t's actually, or else it has that it'll say something's not good. Oops! If you ever do that, just hit Control Z and it comes right back. It's common that you accidentally hit the X all the time and cancel out your own problem, which is very frustrating. All right, so there we go, and you can see that it's exactly the same, which is really convenient.